All right, so we looked at drawing angles, finding coterminal angles, so adding or subtracting 360 or 2 pi, depending on what the case was, converting degrees to radians and radians to degrees, and then how to find the exact value off the unit circle for what's given, or if it's one that's not a known value, how to put it in the calculator. So this next thing is arc length. It's arc length and area, actually. And so these formulas should have been in your notes, but just so that we have them handy, the formula for arc length is S is equal to R theta. And for area, the formula is area is equal to 1/2 R squared theta. Sometimes you'll see a modified formula, and what I usually use, because we're 95% of the time we're finding arc length first, is we can actually use that arc length formula to find area. So area is equal to 1/2 RS, because R theta is in here, and so if we just tack on another R and then the 1/2 to the arc length formula, we have area. So I'll typically use this one, but you don't have to. Other really important thing to note, theta must be in radians. So if it's not given to you in radians, you need to convert it, okay, using your the conversion factor that we got the other day, the pi over 180. And I will say, like, the biggest reason people get these problems wrong is because they don't convert theta. So, 32, R is equal to 4 inches, and theta is equal to pi over 6. So the other thing is these formulas have units, so these values have units, so we should be putting units on our answer when we're done. So first thing is arc length. Theta is already in radians, so I'm good to go. So S is equal to 4 times pi over 6. And you'll be actually typing those in. You're not going to leave your answers in terms of pi for this. You'll go to 2 decimal places for your answers. So this is going to come out to 2.09. And units are inches. The other thing some people end up asking me is, does it matter if my calculator is in degrees or radians for this? The only time we care about degrees and radians is when we're actually plugging them into like sine, cosine, and tangent, and putting it in those values. If we're just putting in like pi over 6, the calculator just sees that as a number. We don't have to be in a particular mode for that. So. All right, so then, like I said, I use this modified area formula to find area. So area is equal to 1/2 times R, so times 4, times our S value of 2.09. And if you have already typed in that 2, like if you've already got on your screen this 2. A second. If you already have that 2.09 in there, if you just hit the multiplication button, you're going to see the word answer pop up on your calculator, and that way you'll just use that number. Somebody wants to type that in and figure out what that's equal to. All right. book back opened up. I don't have enough room on this desk. That's what I'm convinced is the problem. 4 point what? All right, what do we get? Okay. That's one of those things where I'm not going to take off if you're off by like a decimal because I'm going to know it was either you rounded or you didn't. Now, what do we know about units on area? Squared. Yep, so just like normal area problems, these are also squared units. So that would be the area for that one. Let's see if we can get through the last two problems without dropping the textbook again. All right, 34. R is equal to 15 centimeters. Theta is 45 degrees. So what do we notice? We need to convert it. So how do I do that? Now, what is 45 degrees? It's where? Okay, it's on the unit circle, so we already know this one. I'm just setting this up because if it wasn't a value that you knew, this is how we would have to do it. But we know that ends up being pi over 4 from the unit circle. Okay. So like if it's a known value and I don't see this and I just see you have it written as that, that's totally fine because I'll know that you just knew it from your unit circle. So arc length S equals 15 times pi over 4. Two decimal places. Unless it's just a 0. Is it a 0? Okay. And units are centimeters. Then area. I'm going to do this area not using S, so I'm going to use the original area formula just so we can see that one worked out once. So 1/2 times r squared, so 15 squared times pi over 4. And like I said, the answer is going to be the same either way. Doesn't matter, but that way you've just seen both of them worked out. Anyone? Anyone want to share their answer? 88.35. And what are my units? Centimeter squared. Yeah, I said the most common thing that people get wrong is not converting the theta value to radians. The second most common is not putting units in terms of why points get taken off. All right, one more. 36, r is 18 meters, and theta is 25 degrees. So 25 is not a known value off the unit circle, so I do need to actually set up the little table. So this is going to be 5 pi over 36. So then S equals 18 times 5 pi over 36. .85 meters. And area, I'll go back to my normal area. So 1/2 RS. So 1/2 times 18 times the S value. What did you get?
65.57.
Okay, that's what the book had. That's why I was asking. Is that what you said, Maya?
Yes.
Emma? Okay. Did you get it now?
Yeah.
Okay. I was like, I'm not sure.
I don't know why I added 5.
All right. Any questions on those? Or on anything else you've had thus far? All right. Then to add on to what you had the other day, 33, 35, and 37. And since it's Wednesday, I mean, you probably will finish with everything, but it's not technically due till Friday. But if you have not already done 13.3 notes, you should use that time now to do that, because we do need those for tomorrow. Friday, also don't forget the practice unit circle quiz. If you do well enough, you don't have to take it again on Tuesday. So just, yeah.